Hello, my name is Kazam Saranega, and I'm presenting my work on agentic semiconductor quantum device tuning. Semiconductor quantum devices are nanoscale structures that harness quantum mechanics within semiconductors to enable next-generation computing and sensing technologies. They're crucial in breaking computing frontiers. So imagine spending hours tuning a quantum computer, one voltage at a time. Researchers make thousands of measurements, hoping to find the right operating point. So what if AI could do this autonomously in minutes? Enterprise design thinking guided my approach. Researchers need three things: speed, safety, and trust. So I built an autonomous agent with IBM Granite that delivers 50% efficiency gains, zero safety violations, and full explainability through natural language rationales. The result was an autonomous agent powered by IBM Granite on Watson X. Granite makes strategic decisions about which measurements to take, achieving our design goals, which is 50% fewer measurements, zero violations, and full transparency. So I'm going to demonstrate Granite in action. I'll be running my agent on a simulated quantum device with a challenging target, which is to achieve 95% confidence and identifying a double dot configuration. I've enabled Granite and set a debug mode so you can see every decision I'm making. So in this particular test block, I'm trying out a pretty complicated case where, like I said, I'm trying to identify a double dot with a 95% confidence rate. So we're going to start off at the top. So you'll be able to see that in steps 1 to 3, Granite immediately overrides the default strategy. So it's making real-time API calls to Watson X, suggesting alternative measurements. In steps 2 to 7, we hit an anomaly detection event. The safety system triggers a rebaseline, and Granite adapts, suggesting multiple line scans to recover efficiently. In steps 9 to 10, Granite agrees with the heuristic, which shows intelligent oversight. It overrides when needed, confirms when the default is correct. And in the result, at step 10, you see that Granite used over 2,100 tokens. It made over 10 Granite API calls of token reasoning, and 8 out of 10 steps overridden, which is 8% strategic guidance with zero safety violations. We reached 90% confidence, just shy of the ambitious 95% target. And this is what makes Granite powerful, because every decision is logged with natural language rationale, and researchers get full explainability. They can see exactly why the AI chose this strategy. It's autonomous and intelligent with scientific transparency. In the future, I'm hoping to improve my architecture a bit more and try to engage a bit more of ODD to try to make my process and my architecture a lot safer. This is a pretty complicated use case. It's very hard to explain all of this in 3 minutes, but I hope that it does make sense. Thank you.